Hello students, welcome to another video lecture on logic design. In this video you are going to learn how to count in hexadecimal. As you know, there are 16 symbols in hexadecimal. The numbers 0 till 9 and the alphabets A, B, C, D, E, F, which are used to represent the decimal numbers 10, 11, 12, 13, 14 and 15. We will also cover some basic conversions, namely hex to decimal, decimal to hex, hex to binary and binary to hex. First, let's take a look at counting in hexadecimal. In this table, notice that we have 6 columns. The first, third and fifth column display the decimal numbers 0 till 32. The second, fourth and the sixth columns display hexadecimal numbers for the same decimal number. Let's start from the first column. Notice the symbols 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 are hexadecimal representations for the same decimal numbers. But once we reach 9, the next hex number becomes A followed by B, C, D, E and F. These alphabets represent the decimal numbers 10, 11, 12, 13, 14 and 15. Once we reach 15, the next hexadecimal number becomes 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Once we reach 19, the next hex number becomes 1A, 1B, 1C, 1D, 1E, 1F. Once we reach 1F, the next hexadecimal number becomes 20 followed by 21, 22, 23, 24 and so on. So in this way, we can count in hexadecimal. Now let's talk about conversions. Firstly, how do we convert a hexadecimal number to decimal? In this method, we usually use is the positional weights method, a method very similar to conversion of a binary number to decimal. In this method, each hexadecimal digit of the number is multiplied by its positional weights and the product terms are added to obtain the decimal number. Let's take an example. Given the number 4A57.B6 to the base 16 converted to decimal. The positional weights of the integer part are 16 raised to 3, 16 raised to 2, 16 raised to 1 and 16 raised to 0. The positional weights for the fractional part of the number are 16 raised to minus 1, 16 raised to minus 2. Therefore, the octal number can be therefore the hexadecimal number can be written as 4 into 16 raised to 3 plus A into 16 raised to 2 plus 5 into 16 raised to 1 plus 7 into 16 raised to 0 plus B into 16 raised to minus 1 plus 6 into 16 raised to minus 2. This evaluates to, adding these all up, we get the number 19031.7109 corrected to 4 decimal places, which is the equivalent decimal number for the given hexadecimal number. Now let's look at how to convert a decimal number to hex. Let us take an example. Given the decimal number 2598.675 and we want to convert it to hexadecimal. Let's deal with the integer part of the number 2598. Just like converting decimal to binary where we do successive division by 2, you can refer to the double-double method. We can convert a decimal number to hex by doing successive division by 16 and recording the remainder. So let us start with the integer part of the number 2598 and divide it with 16. So we get 16 into 1, which is equal to 16. So 25 minus 16 becomes equal to 9. We get left with 99. Then 16 into 6 is 96. So 99 minus 96 gives you 3. We get left with 38. And then finally 16 into 2 is equal to 32. So we get 38 minus 32, which gives you a remainder of 6. Now we divide 162 by 16 again. So 16 into 10 is 160. 162 minus 160 gives us a remainder of 2. Again, we divide the quotient 10 by 16 and we notice that it is too small to divide by 16. So we get the quotient as 0 and 10 gets left as the remainder. This 10 will obviously be represented as A in hexadecimal. We read the answer bottom to top. Thus the integer part of the hex number becomes A26, where A is nothing but a representation for decimal 10. Moving on to the fractional part of the same number. Recollect that the fractional part of the number is 0.675. Just like converting the fractional decimal to binary, where we do successive multiplication by 2, you can refer to the double-double method, we can convert a decimal number to hex by doing successive multiplication by 16 and saving the integer value of the product. So start by taking 0.675 and multiplying it with 16. We get the answer as 10.8. Record 10. Next, we take 0.8 and multiply it with 16. We get 12.8. Record 12. Again, multiply 0.8 with 16. We get 12.8. Record 12. We will do this one more time. Multiply 0.8 into 16. You get 12.8. Record 12. It is advisable to stop after 4 decimal places. Read the final result from top to bottom. Thus, the fractional part of the octal number becomes 0.ACCC, since A is equal to 10 in hexadecimal and C is equal to 12 in hexadecimal. The final number eventually becomes A26.ACCC to the base 16. Let us now look at hexadecimal to binary conversion. Take an example. Given the hexadecimal number A26.EC converted to binary. This technique is very easy provided you remember the 4-bit binary code for hexadecimal numbers. Recollect the table that I had shown you in the previous video on hex numbers. So let us start with converting. Start with hexadecimal A. Its 4-bit binary value is 1010. Next we have hexadecimal 2, whose binary value in 4 bits is 0010. Next is hexadecimal 6, whose binary value is 0110. Put the decimal point. Next we have hexadecimal E, which can be represented as 1110. And lastly is hexadecimal C, whose binary value is 1100. So this is the equivalent binary number for the hexadecimal number A26.EC. Let us also see binary to hexadecimal conversion. Take an example to convert the binary number into hex. In this method, we simply replace the 4-bit binary code with the corresponding hexadecimal number. Refer to the table for the code, but it is better to learn them by heart. So I rewrite the number as it is, and now starting from the decimal point and moving left, divide the bits into 4 groups each. So we get one group as 0110, the next group is 0010 and the last group is 1010. Now starting from the decimal point but moving right, we get one group as 1110 and another group as 1010. Once this is done, replace each group with the corresponding hexadecimal number. So we get A for 1010. We get 2 for 0010. We get 6 for 0110. The decimal point remains as it is. We get E for 1110 and we get A for 1010. Therefore, the hexadecimal number is 826.EA. There is a small mistake there, it should be A instead of C. That's all for now. Connect to the classroom for further videos and learning material.